because it stopped recording. So,
I think it's A.
okay. And you added 485, and we got 9. Okay. Okay. Good. Thank you so much. Nice work. Shade the region that represents. Who would like to do this one? Let me see. I haven't heard from Logan.
Yes.
So we are working on part B.
Yeah, 1 second. Hold on.
Sure. So shade the region that represents more than 4,420 grams and choose the correct graph. Which of these two you will automatically eliminate? Anyone would like to help?
I can help.
Okay.
So we can eliminate B and C because they don't start at the
So
mean.
it says more than 4,420. So A and B have nothing, right?
Right, and C does not start at the mean either.
So, but we have to start at 4,420 and go to the right. But the question is this piece or is this piece?
I think it's D.
Yeah.
Yeah, it's D.
I agree.
3935 is
because the mean is different. I agree.
Right. That's what I was.
Okay, that's what you were saying. Sorry about that. Yep, of course. Good. Okay, so let's work on C. Who would like to work on C? So they're telling us this area is 0.0228. 0.0228 is this shaded blue area.
I can.
Yes.
It's Emma. It's Emma.
I think Preston wanted to say something.
Yeah, of course.
I had to reread it like 3 times. My brain is slow today.
But forgive me, I cannot see when you want to say something because as you look at my screen, I only see 3 people here. So my apologies if you. I want to keep everybody in line, but I may not be able to see when you try to speak. Forgive me. Sorry, Preston. Go ahead.
I would say B.
So the probability is that the birth weight of randomly chosen full-term baby is more than.
And it is 4,400.
Right, and the first one was the probability is this, that the birth weight of chosen from is less than. Correct. Very good. So we have 4420. Where's my keyboard? Great job. Good. Can we continue? Do we want anything to work on anything else from here, or can we continue with section 7.2? We move on?
Yes.
Okay, so let's move on then. Where am I? I'm here. Good. Ready? Another 20 questions. Let's choose.
We do question 3.
Question 3, let's start with 3. Describe how you can transform a non-standard normal distribution to the standard. Okay, let's talk a little bit about this. We've done this before. This is not new, but let me refresh your memory. So every time we have a normal random variable with mean, mu, and standard deviation, sigma, this can always be changed into, because for every observation that I obtain in the data set, I can create the z-score. So I can always change a normal distribution into a standard normal as long as I define this variable, which I know is normal with 0 and 1. Can anyone remind us what is the Z normal, standard normal? What is the formula?
It's x minus mu over the standard deviation.
That's it. That is always it. Thank you so much. So
That was Emma, by the way. Just
yes. Now I will start learning your voices much faster. Yes. Good. So then what do we choose? I know it's a silly question.
D.
Yes, D as in dog, of course. Perfect.
Can we do the one that you're on right now?
Oh, yes, of course. Yes, of course. A study finds that. Who would like to start this one? And when you read this, you should always write x is normal with 18.82, comma 1.58, because this is always the first step.
I can do this one.
Okay.
A study finds that a carapace length of an adult spider is normally distributed with a mean of 18.82 millimeters and a standard deviation of 1.58 millimeters. Sketch the distribution of the variable x. Choose the
Great job. Yes. So obviously, looking at these three graphs, I don't really need to. I don't really like that idea to start choosing and picking. I know how to graph this, right? The mean has to be right in the middle. And the standard deviation, so this is, if this is the inflection point, this point here has to be 18.82 plus 1.58, and this point here has to be 18.82 minus 1.58. So back to the graph.
would the answer be B?
The answer has to be B. There is no other chance, no other way, right? Because the mean has to be in the middle. Not this, that's the standard deviation. And not this, because this is Z. This is the graph for Z. So before, let me check this. And let me also show the graph for Z. Here it is. The graph for Z, 0, 1, where the inflection points are, -1, 1, 2, 2, and -3, 3. This is the Z. Standard normal, not normal, even standard normal is called 0, 1. Oh, of course, nobody could see anything. So here's Z. Sorry about that. So the mean is in the middle, which is 0, where the inflection points are -1, 1, and then -2, 2, -3, 3. And this is Z, standard normal. Standard normal. So for example, what I'm saying with this is, let's say if I have x equals 20, 30, and 41, and I have the mean and the standard deviation of this random variable, then Z for 20 will be 20 minus the mean over the standard deviation. Z for 30 will be 30 minus the mean over the standard deviation. And for 41 will be 41 minus the mean over the standard deviation. If I call this Z1, Z2, and Z3, and I determine these three numbers, the mean of Z1, Z2, Z3 must be 0. The standard deviation, when I calculate the standard deviation of these three numbers, has to be 1. So I normalized, in other words, I changed the normal random variable into a standard normal. So this number, let's say it's little a, this number is little b, and this number is little c. The mean of a, b, and c has to be 1. The standard deviation of a, b, and c has to be 0. And I created this random variable called standard normal. Okay, perfect. Other problems we'd like to pick here.
question have multiple parts?
Oh, of course, I'm sorry. I always forget. Thank you. Sorry about that. Obtain a standard version Z of X. Choose the correct standard version. So let's choose the correct standard version. Which out of these four, who will you, yes, Madison, I saw that. Which of these four you will absolutely eliminate and not even look at?
Would it be C?
So I will never look at A and B because that's X, it's not Z. Okay, so X minus 18.82 over, yes, of course. So these have to be completely eliminated from the start because I'm not looking for X, I'm looking for Z. Well done. Identify and sketch the distribution of Z.
I'll do this one.
Please.
So off the bat, you can eliminate B.
Of course, of course.
That's
And there is another one that you have to eliminate right away from the get-go.
option A because it doesn't.
It does not have a mean of 0. The mean has to be 0. Very good. Great job. There is more? Okay. Find the z-scores that correspond to the percentage of adult spiders that have carapace length between 17 and 18. Okay, let's stop and talk about this. So this is the probability that X is in between 17 and 18. It doesn't matter if I put the equal symbol or not. This is continuous. Okay, so how do I determine this? I want to show in two ways. I didn't mean to do that. I meant to share the screen, and I'm so sorry, I did not get ready with a calculator. I meant to, and then I forgot. Okay, so we have the mean and the standard deviation. Did I put them on the previous page? Yes, I have them right here. Okay, so we go to second and distributions. And this is normal. It's not PDF. It's normal cumulative density function. Press enter. Thank you very much. Press enter. Okay, so if you have an 84 that is an older version, I'll show you how to do this. Is the same thing. So the lower limit is 17. The upper limit is 18. The mean is 18.82. And the standard deviation is 1.58. And when I press enter, it will calculate the percentage or proportion or area, so 0.17720. So that's one way. Let me just go back to the book. Where is my book? Here it is. Not the book, but you know what I mean. Okay, so the percentage of adult spiders 17 to 18 is equal to the area under the standard normal curve. You can use the standard normal curve, or there is no need because we have the standard deviation. So we don't have to determine the z-score for 17 and the z-score for 18 unless that's what they want. Yeah, that's what they want. They don't want the area. They want us to find the z-scores. Fine, that's okay. And then I'll show you how to determine the percentage or the area with StatCrunch. Okay, so they are asking us to determine the z-score for this. No problem. So it is 17 minus 18.82 divided by 1.58, right? Okay. So this will be the z-score for 17, and the z-score for 18 will be 18 minus 18.82 over 1.58. Can anyone give us these two numbers? And in the meantime, I'll I will go to StatCrunch and get it ready so we can illustrate with StatCrunch as well. I'll open StatCrunch.
I have the answer for the first one.
I'm ready.
I got negative 0.1519.
Good?
I got the second one.
Yes.
It's negative 0.51899.
Negative 0.51899, and this one negative 0.1519. Am I correct?
Yes.
Okay. So let me share my screen. I was getting StatCrunch ready. Okay, so back to where is my book? Where is my problem? My problem disappeared. I lost my problem. Why did I lose my problem? Just because I opened StatCrunch? Oh no. Oh, I opened StatCrunch in the background and it killed my problem. Anyone remembers which problem that was? We may have to start it all over. Oh, maybe it's here? No, it's not. No. Sorry. I'm sorry. I should have not done that. We may have to calculate these again. It will give us a different problem. My apologies to all of you. Anyone remembers which problem this was? 17?
Might have been 3.
Okay. No.
That was it.
Oh, that was it. Okay. Sorry about that. Oh, yes, they gave us 2 new numbers. Sorry. I will never do that again, I promise. Okay, so we have a normal random variable, 19.79 and 1.96. Okay. So it's the distribution of, okay, 19. So, of course, it's A. I'll do the legwork. Okay. Then we have Z is X minus 19 over this. Okay. Because this is something else and the other two. Okay. Good. Identify and sketch the distribution for Z. Okay. Finally, here's our question. Under the standard normal curve between this and this. Sorry, guys. So we have X equals 18 minus 19.79 over 1.96. And the other one is 19 minus 19.79 over 1.96. And if you want me to get punished, I will do it myself. I'll punish myself for doing what I just did. I didn't think that it will kick me out. So negative 0.91326, and the other one is with 9. So this is negative 0.40306. Okay, I got the numbers. And now round to 2 decimal places. Don't forget to put the negative. 2 decimal places, 0.91. And correct my numbers anytime. And negative 0.4. 0.4, 2 decimal places. Okay. So now it's probably going to give us, okay, find the z-score and direction that corresponds to the percentage of adult spiders in carapace length exceeding 21. The z-score and direction. Okay. So for the z-score, let's determine the z-score. Anyone Oh, see? This is the z-score. Okay. So anyone can give us the z-score for 21? And more than 21. Do we have the z-score for 21? Am I muted or something?
You need it rounded?
I have it.
I got it. Yes, ready.
It's gonna be 0.6173.
Very good. Okay. So now I'm going to stop sharing and explain what happens here. So this is the z distribution, the standard normal. Here's 0 right in the middle. That's the mean. And as we know, this will be where the first or the right inflection point is. This will be 1. And where the other one is will be -1, as we know, 0 plus or minus 1. And 0.61, so if this is 0.5, 0.61 will be somewhere here. So if this is 0.61, then greater than is this area. So this is the area or the percent that x is greater than or equal to 21. I want to show how to determine this area. With a given standard deviation, since I already have StatCrunch, or maybe did StatCrunch disappear now because I went back? I hope not. But if I go to StatCrunch, I will not be able to come back here. So let's put the number around to 2 decimal places. So this was 0.62. So let's put this in first.